Good day, guys. Welcome to my channel. Please don't forget to like, share, and subscribe. So today we'll be discussing camshafts. All right, we'll be um, drawing camshafts, and the question or reference question will be this. We'll be using this as our question or practice question. So the question here says camshafts operate by a knife edge follower. Now, from 0 to 180 is the lifts. All right, so we take note of something. We're going to take note of three things, three circles basically: the cam diameter, the cam itself, the thickness diameter, then we have the lift diameter. So here they're telling us that the lift is of 24 millimeter with a simple harmonic motion. That's from 0 to 180. Now all this is going around 360. So we know from 0 to 180 is a lift, with 24 millimeter with simple harmonic motion. Then we have 180 to 240, which is the rest interval. That means it maintains that same length. Then we have 240 to 360 degrees. That's the 4. So we know we're moving from 0 to 360. Good. We are completing the entire circle. Now we have 4. Yes, 4 over 24 millimeter with uniform acceleration and retardation. Now one thing about camshaft is this: we have three major ways, or three major ways they can give us questions, or which questions can come out on camshaft. They can either tell us with simple harmonic motion, with uniform acceleration and retardation, or they can tell us with linear. Right now, each of those ways we have I will practice those ones. By our next question, we should have that one, the third way, ready. Or better still, I think I should be able to project one of it for us. I should be able to project one of it for us. Please hold on. Oh, sorry. Sorry, I'm not sure that will be possible. So basically, we have three ways. They can either ask us to use simple harmonic motion, a uniform acceleration and retardation, or the linear way. Now, either one, they actually the linear way is actually, we are not asked to use that here, but that one is actually very very straightforward. So these two we are going to use here. Now remember, it said we are using the cam rotation is anti-clockwise, while the least thickness of the metal. And I remember I mentioned thickness diameter. The thickness diameter here, they told us around the camshaft is 38 millimeter. So then it told us that the camshaft diameter itself is 24. So those are the three circles we're going to draw. We're going to draw the first circle, which is the camshaft diameter of 24 millimeter. Then we're going to draw the thickness diameter, which that one goes round the cam center with 38 millimeter of thickness. Then we'll have the lift, which is 24. That's 24 millimeter also. So those are the first three we are going to draw. Then, so for the first one, we said the camshaft diameter. Now the diameter there was 24 millimeter. So radius will be 12. Half of it, the radius will be 12. Then, so we'll have radius of 12. That's our first one. Sorry, please let me just move this up here. Okay. Now, the next one, sorry, and I will change this to diameter just for easy. Now the thickness, all right, the thickness diameter, that one is around the camshaft center is 38 millimeter. So we come here. Now we know we're dealing with a diameter of 38 millimeter. Just 38. We have the second one. Now we now have the lift. Now this is the problem with the lift. They said the lift is lift of 24 millimeter, and it also dropped it fell back to another 24. So the total height we're looking at is just 24 millimeter. Now how do we do that? Instead of us calculating the radius from the thickness, right, the radius of this one, what we'll simply just do is to come here, and you can use this other method, the center. Now instead of you going through that, sorry, so from here you should have this line here. Click here, take it up by 90 degrees, but make sure it's what, 24. Good, we have that. Now after this, you now need to check, draw a circle of radius from the center and make sure the lift is just 24. Good, so we'll have that, and that's how we get our first three circles. So we've done the part of the camshaft itself. All right, this one of radius 24 millimeter. That's what we have it here. Sorry, oh shoot, 24 millimeter, and that's radius of 12 since we're using radius. Good, so we have that. Now the next thing, all right, is to divide these lines. Now the division of lines, I think, except if specified in the question, all right, here in the textbook they decided to use they decided to divide the line. Now you know from 0 back round to this point is 360, so they decided to use a division of 15. All right, now, well, except if the question specifies it, please, I would advise you use 30. The reason why is it saves you a lot more time in the exam. All right, the time given in exam, every student knows that it's not going to be enough. So to save your time, please just use a division of 30. All right, divide each part by 30. But I will go with what we have here in the textbook, and the division used there was 15. So let's look at now. There are ways to do that. You can come here, all right, and use the division rule, then go through all the whole process. Or what I mean by that is this: you come here, you select your object, you divide, go to draw, select the division tool, the divide tool, select the object you want to divide, then they ask into how many segments. Now we are going round because we're using 15. You can just do 15 divided by 360 divided by 15, and that will give us 24. So you can divide it into 24 segments, all right, where you have 12 on one hand, 12 on the other side. So you can do that. Then after dividing it, when no point comes out still, you come to this utilities idea point style, click any of these point style you want. I love using this a lot. So you click this, it comes out, right? Now you can do this, then you start picking the lines from the center one after the other. All right, start picking the lines one after the other around the entire circle. Now if you do that, it's still fine, but there is a shorter way that I believe we can do that without drawing lines, because remember, one of the things we're trying to do is to save time for the exam. We're trying to save time, so we'll have enough time to attend each questions. Now because this AutoCAD is very straightforward, now what do we need to do? The first thing you do is you come here, you draw a line. Oops, sorry. Now you come here, you draw a line, make sure the line is straight like that, perpendicular 90 degrees. Now you come here, you select the line, then you come to your array and use your polar array. Now from here you select the center point of the array, which is this point, then your I for number of items. Then how many are you trying to create? You're trying to create segments, a 24 segment, right? So you just have that. There you have this. Oops, sorry, I think I must have, so sorry, let's do that again. Let's say page 25. Now array, center points, good, then 24. Oh sorry, I, then 24. Good. So now we have that. You simply just draw all the lines you need instead of you marking them, then drawing a line, drawing a line, drawing a line, drawing a line. It saves you all the whole time. Now it's best you number them. You can do that, or we know we are working with limited time in the exam hall. Then you draw two lines. This is the next step. From this point, you draw a line, you extend it. Now, when coming down, remember the lift's length is 24. So you just 24 down. Now it should be tangential to this line, or it should meet with this point. That's the rule. If it doesn't meet, then that means there's an issue with your dimensions. All right. Now after that, we'll now pick a starting point. We'll pick a 0 point. Now remember we're using 15 here. We'll pick a point 0. Let me see. Pick a point 0. Now because we won't try to draw a line from here, it might not work. Let's see. Let me just pick a point here. Let's pick a point here. Good. Now the point 0 we are going to pick, please, whatever you do, make sure it doesn't touch this circle. Whatever you do, try your possible best to make sure it doesn't touch this circle. Now we are now going to divide what we have here. We are going to make a lines with spaces in between them. Now remember, how many lines did we have when we try to divide, because we're using 15, all right, a division of 15. There are 360 divided by 15, so we are going to add 15, like 15, 0 plus 15 plus 15, 0 plus 15, that's 15, 15 plus 15, 30 plus 15, 45 plus 15, 60. We continue like that round this circle till we get to 360. So that's the same thing we're going to do. We're going to make lines, but when we did 360 divided by 15, we go what, 24. So that means we're going to have 24 lines, all right, 0 and then 24 lines. So that is altogether 25. Good. Now how do we do that? We come and use the offsets. All right, offset is here. This sign here, you should see it here. Your home tab. Come to your offset here. You have this. Now you can use true offsets, but because we want to make more than one and you want to make it very, very fast, I would advise you use this. But first, let's look at this. The first issue we're going to have is this spacing in between. Now the spacing in between is also determined by you that you're going to draw, you who is drawing the camshaft profile. That's what's is also determined by you. So you can use 5, you can use 4, you can use 3, you can use 2, but I would advise you make it spacious, like space it out very well. I mostly use 5, around 5. Yes, that's what I use. Or we can decide to use what, 4. Okay, let's use 4 for now. Now after you've used 4, you want it to automatically continue instead of you going through the whole stress of selecting it, then pressing 4 and pressing enter again. Now instead of you going through that long process, you press escape, you come to the fillet here, the offsets. Now instead, when you get to this true option, don't click anything. Instead, the spacing you desire, the spacing you want to use, as now, which is 4, you press it, then enter. Then it asks you to select object. You select this. All right, now you see that it automatically gives us the spacing. You left click on this one again, you move the mouse to the side. Now whether you move it to the left or you move it to the right, it's going to make sure it's what, 4. That's just 4 millimeter. That's the measurement you've stored on it. So you left click again, you left click on this one, left click again, left click, left click, left click, left click. Now we're supposed to make 25 in total. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Good. So that means this part we don't actually need this part. So what do? We can just come here and trim it off. We don't need the side, we don't need this, we don't need coming, sorry, don't need you anymore. Good. Now we've had this part. Now let's go back to the question, please. So now we know our starting point here is 0. Let me just include that here. Our starting point there is 0. Oops, very small. Incoming. So the text height, let me use 4. Good. Oops, I think that's too big. Text height. Use 2. Good. So we have that 0, and the last one here we have is 360. So we can write that 2. 360. 360. Then we come to, we highlight this, and we come here the text height. Since that one is a longer value, let me just use 1. Good. Just so we know what we are doing now. So we have 0 and we have 360. Now if we go back to the question, we'll see here that we have from 0 to 180 we have a lift with what? Simple harmonic motion. Now anytime we have simple harmonic motion, what we try to do is to draw a semicircle. This is what we try to do. Anytime you hear a lift or a fall of simple harmonic motion, if it's a lift, you start this from the beginning, start this circle from the beginning. If it's a fall, you start it at the end. All right, this is for lift, this is for fall. Let me make sure you see that. This is for lift, this is for fall. All right, so here we're having a lift, so we have this. So now let's go back to the drawing. Now for the drawing, okay, good, we're going to have the semicircle here. Now how do we go about the semicircle? You come here, click the circle, you can use the center and radius, and start your radius from the center of this line, which is 20, half of 24, which is 12, and take it to either up or down. All right, now you have that. Then you trim this other part off, you don't need it. This other part, you trim it off. Now please, I would advise you extend this part of the circle, this part of the line, so that these circles don't cross over each other like this, because it can attract negative marking. So let's just continue with that. Okay, sorry, please extend this one here, and extend this one here. Okay, good. So we're good. Now the next thing to do is to divide this line too. Now just like we divide the entire thing here into 24, we also need to divide this small circle. Now half of that 24 will be 12, but remember we are starting from 0. All right, I came across this issue multiple times when I started it too, and it gave me headache, because by the time I was to complete the graph on this part, I discovered that I was 1 point short. So in order not to get that, also remember that you can just do what? Set your the numbers. Remember, you're starting from 0 to 1 to 2 to 3 to 4, like that, till you get to what? 12. But in this case, because 0 plus the 12 will still give you 13, so we know what we are actually, the segments we're trying to create here. So we start with a line just like we did here. Starts with a line there. Good. We pick these points, and we come to our polar array. Good. And center point of the array, we pick that point. Now there is a problem. The polar array just wants to complete the entire cycle, and we don't need that. So it brings out this section for us. Then we come here where we have this field of 360. Change it to 180, please. 180. Now the number of items you need. Remember, we need what? 13. All right, not 12, because we have 0, then 1 to 12. So that we need 13 of them. So 13, and we have that, right? Now you can exit your array. Good. Now we need it to be to face this part, not the 180 towards this downside. And how do we correct that? You highlight this. You highlight the entire array. Then you right click and come to rotate, or you can type rotate and just type rotate. Good. You can do that, or you can right click and then it will ask you to say, specify the base point. Just specify this center, then drag the line down, or drag the line down. All right, then you have it. All right, these are simple tricks and fast ways to actually go about this. It saves you a lot of time during exam. So we have this. Now remember, the numbering of this semicircle will start from 0, which will be here. 0. Coming, please. Text height. Let me set this to 2. Good. So it's starting from 0 down to this point. All right. So we have 0, 15. Here we have 0 to 15 to 30 to 45 to 60 to 75, then to 90, continue down to 180. Good. Now we have that. Now the next thing is to keep on now doing something. Remember, let's go back to the question, please. Remember, the question here says from 0 to 180. All right, we have a lift of what? 24 millimeter. Good. Now we know this whole part starts from 0, so we know from this line, now from this line to this line is 15. 15 plus 15, this is 30, plus 15, this is 45, plus 15, this is 60, plus 15, we have 75, 90, 90 plus 15, that's 105. 105 plus 15, 120. 120 plus 15, 135. 135 plus 15, that is 150. 150 plus 15. Coming. Invariably, a shorter method to do that, please. Just do 180 divided by 15 instead of us calculating. So 180 divided by 15, that will be 12. So you just have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now what I do is, when I get to this part, I just sort of tick in the line. Now line weight is what you just come and use. I use this. Okay, it's not showing yet, so what do? I come here. All right, this show and hide line weight, you can put it on. When you put it on, that line becomes thick. Good. Now the real work starts. So what we do is simple. We pick each point and extend them. Remember, this is 0. 0 meets 0, so we start from the bottom. Since it's a lift, so we are starting from the bottom. That's from this point to the first line. Good. That's the first one. The second one will be from this second point to this part. Good. The third one will be from this to this. Good. The next one will be from this to this. The next one will be from this to this. The next one will be from, instead of starting the line here, just start it from this point to this. Now the next one will be from this point to this point. The next one will be from this point to this point. The next one will be from this point here to here. Good. The next one will be from this point to this. Then the next one will be from this point to this. Now earlier on, remember I said something of I had issues with this, so I was always 1 point short. I always had a free line somewhere, so I wondered where that one came from. So we have this, then we have this last one here filling up to these points. Now how do you draw your arc? Right, you can come to this arc point and use your 3 points. This is what I use normally. Then before you start, just to make your work look more attractive, you can thicken the line, maybe thicken it more, maybe use like 0.05 millimeter. Now you're starting from the 0 points, all right? So starting from this 0 point here to this point, all right, to this point. Good. So that's the starting point. Now because it's just 3 points, all right, it stops. So you come here, you click it again, you continue the same thing, 3 points. You come here, click it again, you continue the same thing, 3 points. You come here again, continue 2 and 3. Okay, you come here again, 1, 2 and 3. You come here again, you have 1, 2 and 3. Good. So now we've completed that first part of the question that says from 0 to 180 we have what? A lift of 24 millimeter. Now remember, how did we get that? We know that from this point, this part to this part is 24 millimeter, right? Good. So we had the lift, the simple harmonic motion lift. This is basically how it's just done, guys. All right, that's simple harmonic motion. So we know that when it's a fall, instead of you drawing the semicircle here, you come to this end point. This is where you draw your semicircle from. All right, and repeat the same process. Check the number, the total number of lines you divided, or the number you divided this one by, divided by 2, add 1, then use it to making your word semicircle. That will even help you avoid what the extra line that might give you a headache. Now let's go to the second part of the question, please. The second part of the question says from 180 to 240 we have what? A rest interval. So that means the graph or the line will remain at this point from that 180 to 240. Now what's 180 to 240? 180 to 240 we have, you can just say 240 minus 180. 240 minus 180 will give you 60. All right, so you have an interval of 60. I remember we're using 15, so we can have 0 to 15 to 30 to 45 to 60. So we have this point here. That's where we have then taking this line to line weights, then use the 0.3. Remember it's 0.3 we use for this one too. Oops, I taking the last one, no problem. Now we have this, so this point, this middle point is where we have our rest interval. Now what do? You can use a straight line, since it's straight line straight down to this point. Good. So we have that. All right, good. Now the next one, the next part, which is the last part, says from 240 down to 360 we have a fall of what? Of 24 millimeter. Also, that's from the top to the last part, with a uniform acceleration and retardation. Now most of the time in some exam questions you see something like this there. You see this UAR, that's what the uniform acceleration and retardation. All right, the reason why it's given that same name, you know, acceleration is when it's moving, when the slope is positive, meaning when it's giving something like this, when we have a positive slope. Now retardation is this, so we understand what they mean. So what they are just trying to use, this acceleration and retardation, whichever So how do we draw that one? Now this is what we do. We count the number of lines we have here. I'm talking about this, from this point to this point to this point to this point to this point, all these points. Good. We count all these ones, right? Then we look for a middle line. There is always a line that will always be at the middle, because if we count them in total, it will give us an odd number. So we can count from 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 2, that's 4.5. So just count 1, 2, 3, 4. All right, 0.5. This is the line we are looking for. So this line is the line we need. To the left we have 4, to the right we have 4. Now what do we do about this line? Now when we count these other lines from here, ignore this, count from here. You have 1, 2, 3, 4, 5, 6, 7, 8 lines. All right, so we're going to divide this line into 8. Now remember, uniform acceleration and retardation, this is the process we've done for simple harmonic motion. This is uniform acceleration and retardation. So this is the step to do that. So we come here, divide the line by the total number we've counted. We counted from here to this part to be what? 8, right? Now this is the line we picked, if I'm not mistaken. Yes, so this is the line we picked. We select it. Sorry, yes, we select it. Let's come back again and do that, please. We select the object. Good. Now how many segments do you want to divide it into? We are dividing into what? 8 segments, right? Good. Now no point still shows, so we come to utilities, point style, this. So we have this already. Good. Now how do we what's the next thing to do? The next thing to do is simple. We draw lines from this point, because this is where it's falling from. All right, if it was falling somewhere else, we start the line from there. We draw lines from here, we draw lines from here to intersect each of these points. We'll have something like this. This is what I mean. We draw the first line to intersect these points. Oops, sorry, I have to reduce the line thickness. Back to layer. Good. Now we draw a line, all right, from this point to intersect this point. That's the first thing. The second one, we'll draw the second line to intersect this point. Good. We draw the third line from here to intersect this point. Now I've been doing this for quite a while, so I'm used to this process. But if you want to know where you will stop for this top part, you can just come, start a line from here and drag it to here. It will cross out one of the points which you did, so you know whenever line you are drawing from this part must stop before you get to this point. All right, so we've completed for this point. Now the next thing is also to start at this other opposite end. We'll start drawing a line from here to this point. We'll come back again from here, repeat this same process to this point. We'll come back again from here to this point. Good. Now we have that. Now what is the why did we draw all these points? We drew all these points for this first one here. We are interested in this point. We're interested in this point for the second line. For the third line, we're interested in this point. Now why are we interested? Because we are going to have this. Now please, I would like to take in my line back. So we have this. Now we start from here. Now remember, a fall of what? 24. So we are going to complete it from this point, remember, to this first line. All right, first line, first point. Good. Second line, second point. Good. Now you continue again from this point to the third line here. Good. Now to the middle point where this line intersects, right? The midpoint. Good. We continue again from this point. We continue to the next line, this point, to the next line again, this point. This is what we are having. All right. Now from this, oops, sorry, I clicked arc. Yes, from this point to this line. Good. Then to the last point, and there we have it, guys. This is our calm profile. This is from what we have in the textbook. This is what we're going to draw. Now it remains something. We are meant to pick up this part, right? Now how do we draw this part? That's the direction of the follower. All right, Now, how do we draw that? Now, remember, we're dealing with a knife edge. All right, that's why we usually that's why this sign is there. We're dealing with a knife edge, so that one doesn't actually have a specific dimension. You can actually draw any dimension from there. So the knife edge, remember, is from here. All right, so you can actually use any dimension to that, and by any dimension I mean this. Just oops, sorry, I have to make sure this line is back. Okay, so we have this. All right, let me use 2 at 45, 2 at 45. Now please, how I did that was all this how the blue marker moved from one part to the length, from the length to the angle, was after I specified my length, which was 2. The next thing I did was press tab. That will move to the angle dimension, and I decided to use 45 on that. Good. So I can just pick this and mirror this instead of me drawing it again. Just pick it and mirror this. Select the first point, which is this point. So I'll use this. Good. Good. Now just pick a line. Say, let me use 5. 5. Yes. 19. 5 here. Also 5. Good. So that's how we had that knife edge. This one here we have here. That's how we had that. Good. Now, how do we get the rest of the diagram? This part that is thickened round this part. How do we do that? Simple. What we need to do is this, and it's going to be a bit stressful from this point, but you have to be. Now you look at each of these parts. Remember, from here we have 0. This part has a dimension. 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 Now pick each of these dimensions. Now remember, this is 0 to this point, which is 15. Let me just make it 15, 30, 15, 30, 45, 60. Here is 60. Alright, so you can just put it there for us so that we can mark it down. Good. So we have 60 here. Alright, so remember, we have 60 at this point, so we continue that way. So the same thing happens here. We have 0 at this point. We have 0 at this point. And it continues that way. 0, 15, 30, 45, and we have 60 here. 60 here. We have 60 at this point. Alright, good. Let's see. Let's increase that one to that too. Good. So we have 60. So remember, we are going this way. Now this is because the lift, we said, is going and from the question. So it's given to us from the question. Yes, that the least thickness cam center diameter. Now the rotation, the cam rotation is what? Anti-clockwise. Alright, so as the cam is going clockwise, the lift will go, as the cam is going anti-clockwise, the lift will go clockwise. That's the rule. Alright, that's why we are going in this direction. Alright, which is the anti-clockwise movement of the cam. Now let's go back to what we have here. Sorry. Oops, it seems computer is budging. All right, good. I believe we are on point. Good. So we are moving in this direction now. What do we need? Now what we need to do is this. We are coming and we are looking at the dimensions of each of this one and transferring it to each of these lines. That's what we are doing. We're looking at the dimensions and then transferring it to what each of these lines. Now let's do that together. So we'll have, for example, from 0, all right, the next part we have is what, 15. The 15 we have, what's the dimension? You can just come here and use this. Now the dimension is 0.2993, right? So we'll come and transfer that to this point. From 0 here, remember 0 to 15, 0 to 15, we have 0.2993. So you can do this. Let's make this line thicker. Okay, 0.35, 0.3. So 0.2993 line. From here we have 0.2993. 0.2993. All right. Now it aligns with the angle 105. That's why I'm not bothered. So I click enter and I go. Now you see where this one is. Very, very tiny at this point. All right. Good. We go through with the second one. Go through with the second one too. We come here and check the dimension from here to here. From here to here. From here to here. Let's just keep on doing all of that. Save us a bit of time. So this is, most time this is how stressful or how tasking it is. That's why at some point you need to learn how to save time. You need to learn how to save time so that all these things won't delay you. Okay, sorry about that. Okay, so next one we'll have from this point to this point, from this point to this point, from this point to this point. Now from this point to this point. Good. So we have that. So now how do we transfer each of these? So we transfer by looking at this each of these points, then transferring them. So after 0.2993 we have 1.5029. 1.5029, that will be the next one. 1.5029 here. 1.5029. Yes, we have that. Now you can see it's increasing. From this point we're going to this point, right? Good. So from that we'll check again. We'll have 3.4147. 3.4147. That was the next one. 3.4147. 3.4147. Just hold it up here. Let's say 3.4147. Good. For the next part we'll have 5.9047. 5.9047. 5.94047, right? Sorry. Oops. 5.9047. Good. So we have 5.9047. Sorry, hold on. Then the next one, after that 5.94047, 8.7241, 8.7241, 8.7241. So that will be from here. Just stop it here. 8.7241, 8.7241. Good. And the next one we'll have is 12.0. Now after 12.0, 15.0248. 12.0 and 15.0248. 15.0248. 15.0248. That's the next one. 15.0248. Alright, good. Now after that we have 17.9238. 17.9238. 17.9238. 17.9238. Good. Now after that we have 20.3474. 20.3474. 20.3474. 20.3474. Good. We have that. Then after that we have 22.3256. 22.3256. 22.3256. 22.3256. Oops, sorry. 22.3256. 22.3256. Good. 22.3256. Then we have 23.5139. 23.5139. 23.5139. Good. Sorry about that. I have 3.5139. So we have this. Now I think that should be this. Then the last one is 24. Now remember the height from this point to this point is just what? 24. Sorry, ignore that. The height is just what? 24. So we come here and we draw a full line of what? 24. We know from here to here is 24, so we just leave it. Now we for the next four lines, for the next one, for the next yes, for the next 1, 2, 3, 4 lines, we maintain that length of what? 24. So that's what we come and do over here. For the next 4 lines, we maintain that length of 24. Then we have 1, we have 2, we have 3, then we have 4. Good. So that's what we have. All right. Now for the remaining ones, the subsequent ones, after we've drawn all of that, we now start again. Ooh la la. Sorry, utilities points. Due to the zooming in and zooming out, we already have this on the line. So let me just erase that off. Good. So the next point we are from here is this point, this point, this point, this, and this point, and the last point. That's what we're going through again. Now how do we go? We go through the same dimensioning. Now please forgive me, this is still going to be as long as the first one. Good. Then I believe the last one we have is what? 0. So we continue from where we stopped. Alright? Continue from where we stopped. Now where did we stop? We stopped from this point. We stopped at this point. So that means the next one we're doing is 23.2167. 23.2167. Continue that 23.2167. You can just bring it here just to maintain the angle. Alright, that's why I'm doing this 23.2167. We have that 23.2167. That's for the first one. Now 21 is the next one. Then we have 17.2262. 21 is the next one, then 17.2262, right? Seventeen point two two six two. This one is 21. Then we have 17.2262. Seventeen point 2262. Good. So we have that. Now after that we have, after 17.2262, we have 11.9809. 11.9809. 11.9809 from here. 11.9809. Good. Then after that we'll have 6.7357. 6.7357. 6.7357. 6.7357. Good. Then we have two more readings to go. Then we have 2.9905, 2.9905 and 0.75. 2.9905 and 0.75. So we have 2.9905 here. 2.9905. 2.9905 and 0.75. Then we obviously know the last one is what? Is 0. So we 0.75. Good. So we always know the last one is 0. So we know it's coming back, right? Good. That's this one here. Alright. Good. So we can erase all of this. We erase those off so we don't make our work look. So we have this, we have this. Good, that one is gone. We have this, we have this, sorry. Okay, we have that, and all of that is going. This is going, this is going, this is going, this is going, this is going. I believe that's all, and this one too. Good, so we're having all of that living. Good. Now the last thing to do in on this diagram is just simple. We come to our line thickness. Alright, now remember we use 0.5 for that one, so you can use the same 0.5. Then we start using our arc. So our arc is starting from this 0 point, alright, to the tip here. Remember, it's to the tip of this line here. Alright, So we are moving it to this point here. All right. Now we continue that same trend from here to this next point to this next point. Good. Now continue again. All right. We say from here to this point, then to this point. We continue again and say from here to this point, and then to this point. Good. We continue again and say from here to this point to this point. From here, complete it. So I believe we are done. So this is how we draw the shaft, all right? The camshaft using the knife edge, right? And remember, these are profile. Remember when we have some simple harmonic motion, and when we have the uniform acceleration and retardation. Now the linear is just as the same thing as this. Is the only difference is the linear is even the same thing as this simple harmonic motion. The only difference is we don't draw this. We don't add the semicircle to that. All right. Now these are the two, and this is based on this question. You can pause the video here. All right, and check through the question. You can look through the question. You can pause the video and look through the question again. Then go back and check. And if you believe any correction needs to be made, all right. Now, please don't forget. Remember the two things that are very important. The camshaft is rotating, all right, clockwise. Sorry, the camshaft is rotating anti-clockwise. So the lift itself will be rotating where clockwise. So that's why we have a numbering from 0 to 15 to 30 to 45 this way. All right. Now I believe I made an error putting 60. 60 is actually supposed to be here. Sorry. Oops. Sorry. Okay. 60 is actually supposed to be at this edge here. Let me put it here. Hold on, please. Good. No, but 60 is actually supposed to be here. So it's supposed to run through this way. Since the camshaft itself, this one is going in this direction. So the lift will be going in the opposite direction for sure. So this is the way we can draw our what camshaft what profile. And any other questions can be put through the comment section, and I will be happy to answer them for you. So please also don't forget to like, share, and subscribe. I'll be treating other questions as fast as I can, and as I'll make it more. I'll explain more to the best of my knowledge. So see you guys again next time. Thank you.